Welcome back to Geometry 2.3. We're going to talk about deductive reasoning. We are continuing and learning about the lawyer part of geometry, which will lead us to the paper part of geometry, something called writing proofs. Okay, you can do it. It's the part, I'll give you a secret, it's the part everybody thinks is really hard about geometry, but not you. You're going to do great at it. I have had some kids who love this, so it might be you. You might be the one. All right, so let's review what we've learned so far. We learned that we can write conditional statements. If A, then B is the way I like it, but it also is considered proper to write if P, then Q. And I've told you, I'm pretty dyslexic. So to me, I'd much rather have A and B. So, but, you know, and hopefully I didn't write anything backwards up here. But normally, a lot of times it's P and Q, okay? So the converse is if B, then A, or if Q, then P. If it's by conditional, it should be able to go both ways. Both ways are true. You can write it both ways true with P and Q. See how it was just one way here? Or also it could be written P if and only if Q. That's by conditional also. I put that in parentheses because we're going to practice these with these statements, but we won't do all of them every time. The main four we're going to do is that we'll be given the conditional, we'll do the converse, the inverse, and the contrapositive. Okay? The inverse is you add not to the conditional. Not A, then not B. And the symbol for doing it with P's and Q's is that little curvy line. Curvy line P means not P, then not Q. Curvy line Q. And then the contrapositive, you switch them and negate them. So it's not B, then not A, or not Q, then not P. And then the last thing we're going to ask, is this true? And a lot of times it's not, because truth has nothing to do with this. And I always think that's funny that this is the lawyering part of geometry, and this part of it, truth has nothing to do with it. Except we ask, is it true? Alright, so we're going to do this one. If the sun is out, then the weather is good. This is the hypothesis, this is the conclusion, this is the if, that's the then. Okay, so conditional, if the A is the sun is out, the B is the weather is good. So the converse would be, if the weather is good, then the sun is out. The biconditional would be, the sun is out if and only if the weather is good. Or you could say it, the weather is good if and only if the sun is out. The inverse is, if the sun is not out, then the weather is not good. And the contrapositive is, if the weather is not good, then the sun is not out. Now, is that true? Depends on if you like rain or not, right? And I think weather can be good if it's raining, if we have a big drought and we need rain, but there you go. Alright, so let's try this one. So we'll do conditional, converse, inverse, contrapositive. If angle 3 measures 90 degrees, then angle 3 is not acute, because it's right, correct? So now let's do the converse. If angle 3 is not acute, then it measures 90 degrees. Is that true? No. Something could be obtuse at 120 and it's not acute. It doesn't mean it has to be 90 degrees. Okay, let's do the inverse. We're going with not. If angle 3 does not measure 90 degrees, then angle 3 is not, it is acute, because we have to switch the positive or negative. And this is negative, so we switch it to positive. Let me do that one more time. So we're going to make it switch the positive negative. So we're doing inverse. If angle 3 does not measure 90 degrees, then angle 3 is acute. Is that true? No, it could be 120. All right, let's do the contrapositive. We switch them and negate them. So if angle 3 is acute, then angle 3 does not measure 90 degrees. Haiku poetry. You just do it. You don't even have to think about it unless they ask you, is it true? Okay, let's do the next one. If it is raining, then the soccer game is canceled. Converse, if the soccer game is canceled, then it's raining. Inverse, if it is not raining, then the soccer game is not canceled. Contrapositive, if the soccer game is not canceled, then it is not raining. Getting easier? Let's try this one. If the car will start, then the battery is charged. Okay, so that's conditional. Let's do the converse. If the battery is charged, then the car will start. That's a lie, isn't it? You can have a charged battery in a broken car. Okay, let's focus though. All right, now let's do the inverse. If the car will not start, then the battery is not charged. Also not true. Contrapositive. If the battery is not charged, then the car will not start. That one's true. So, a lot of times the conditional and the contrapositive will be true when the converse and the inverse is false, or the conditional and the contrapositive will be false when the converse and the inverse are true. They go together like that, usually the true falseness of it. Alright, so what we're learning about is deductive and inductive reasoning, and we talk about this in science class when I teach that too. Deductive reasoning uses facts, definitions, properties to make logical arguments. Inductive reasoning uses patterns and guesses, and really both have a place in science. Sometimes you have to guess with a hypothesis and then go test it. But with math, we like this deductive reasoning one. We often though in real life, we use inductive reasoning. We see patterns and we make guesses and predict what's going to happen. Now, there are two laws of logic that we're going to talk about. The law of detachment, and it's that if P, then Q is true, and P is true, then Q is true. So it's like P then Q is a true law. Let's see, let's not worry about if it's true or not. I'll just make one up. If you see contrails, then it's going to rain tomorrow. Let's pretend that's generally true, but certainly not now. No planes in the sky with the COVID thing. But in general, that's sort of a true thing. So let's pretend it's always true. Okay? So if P and Q is true, and P is true, I see contrails in the sky, then it will rain tomorrow, Q is true. That's what that one is. The law of syllogism, it doesn't look like that's how you say it, but that's how I've heard it said. The law of syllogism is important. And it's so important to geometry that later we're going to call it something else. Probably because syllogism is so hard to say. And it's so important that I have made up a hand sign to help you remember it. So like if we were in class and I'm looking at you wanting you to say what the other name of it I'm going to teach you later is, and you're staring at me blankly, I go and look at you with purpose, and then you go, oh yeah, and this is what it is. It's that if A then B, and if B then C, then A then C. Let me explain to you what that means, okay? If P then Q and Q then R, then P then R. So I'm going to show it to you down here with this one, okay? If line segment AB equals line segment CD, this line equals that line, and line segment CD equals line segment EF, then we can conclude that line segment AB equals EF. So let's just say it like this, 1, 2, 3. If line 1 equals line 2 and line 2 equals line 3, then I know line 1 equals line 3. Okay, this is really important. We're going to do it with lines and triangles and everything else. And this is the symbol for it. More fun with sound effects. All right. Now here is some use of the law of detachment. Okay. Jamil knows if he misses practice, then he doesn't get to start the next game. He missed practice on Tuesday, so he knows he won't get to start the game on Wednesday. That's an example of deductive reasoning. He used facts to come up with that idea. It could be inductive reasoning if he's seen it the coach doesn't enforce this and he's thinking maybe he gets to play anyway. Then it'd be inductive reasoning. And it's also the law of detachment. P then Q, and P is Q, so he knows Q is true. No start Wednesday. Alright, so a little bit more of this lawyering thing. It's not too bad. You can do it. And we're going to get there. We're going to write proofs. Yay! Math is fun.